Welcome back. Continuing on in our very first review unit, we're going to talk about systems of equations, what they are, and what a solution is, and then how to solve them by substitution. So a system of equations is two or more linear equations that have both x and y or a and b, as long as it's two variables, that we can find out if they cross, if they don't cross, and use them to help us find out when they're equal. If I'm solving a system, we can graph them. If you get them into y equals mx plus b, you can graph them by hand or graph them in your graphing calculator. And we're looking for visually where the lines cross or intersect on the graph. And that intersection point is xy. It's an ordered pair. If we're solving algebraically, which is what we're doing with substitution and elimination, then we're looking for an ordered pair, xy, that makes both equations true. Substitution is when we take one equation and substitute it in for a variable in the second equation to solve, and then resubstitute in to finish the answer. Here are some steps that we can take. For this system that I have up here, we can solve for one of the equations with x or y. For me, I find it easiest to look for x or y that's just got a 1 in front of it. Now remember, they're not putting the 1 there, but in essence, that's what it is. And so I'm looking for something with a 1x or a 1y, so I don't have to do too much work to get my variable alone. It also helps really with fractions, if you're not a fan of fractions, to do that. I'm going to pick this top equation then, because this is a 1x. I'm going to take that 1x and get it alone. So I'm going to subtract 4y to the other side, and I have x is equal to 8 minus 4y. Now that I've done that, I'm going to take that second equation that we haven't done anything with yet, and because this is x equals, I'm going to plug it in for x in the second equation. So I have 2x minus 5y is equal to 29. And the only thing that I'm changing is I'm taking what I solved for x in here, 8 minus 4y. Now I can distribute. 2 times 8 is 16. 2 times negative 4 is negative 8y, keeping that negative 5y, and the equals 29. I'm going to combine my like variables. Negative 8 minus 15 is negative 13, minus 5 is negative 13y. I'm going to subtract the 16 to the other side. Please make sure that you're keeping that negative sign with the 13. And 29 minus 16 is 13. Divide by negative 13 on both sides, and I get y is equal to negative 1. Now I can take that answer and go back up and plug it in for x to find, or for y to find out what x is. So I can plug it into this y in the first original equation, this y in the second original equation, or I can plug it in for this y. It doesn't really matter. We'll all get to x in some way, shape, or form. I like to use this last one because we've already got x alone. So 8 minus 4 times y, which we found to be negative 1. Negative 4 times negative 1 is positive 4, and 8 plus 4 is 12. So we have x is equal to 12, and y is equal to negative 1. So that makes my solution 12, negative 1 in ordered pair form. All right, I'm going to take a look at this next one. So I'm going to solve this top equation because it's got a 1y here. To get that y alone, I'm going to subtract the 9 to the other side. Remember, we can't subtract 9 from the 2x because they aren't like terms, so they're just going to sit next to each other. And we get y is equal to negative 2x minus 9. I'm going to put that equation in for y on this bottom one because I haven't used that bottom one yet. 6x minus 5y equals negative 19. And again, I'm plugging in negative 2x minus 9 from right here. So to solve this, I'm going to distribute, keep that 6x. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 9 is positive 45. And then we keep the equals negative 19. My like terms are 6x and 10x to make 16x. I'm going to subtract the 45 to the other side. We have 16x is equal to negative 64. Divide by 16 on both sides, and x is negative 4. Now I want to take that x is negative 4 and plug it in for x. Remember, it doesn't matter if I plug it in for this x, or this one. I'm going to pick the last one because y is already alone. And then it's just an order of operations problem. So I'm going to plug in that negative 4. We have negative 2 times negative 4 is positive 8. Minus 9 is negative 1. That makes our final answer negative 4, negative 1. The second one is a little bit different, and the reason I say that is because they're both already solved for y. So I don't have to do any work to get one of the variables alone. I'm just going to take the second one and plop it in for y on that first one. Or you could do vice versa. It really doesn't matter. If I do that, it looks like this. Negative 4x is equal to 3x plus 14. I'm going to subtract 3x to the other side. Negative 7x equals, those add to 0, 14. Divide both sides by negative 7, and I get x is equal to negative 2. So I can take that negative 2 and plug it in for this x or this x. It doesn't matter. I'm going to use the bottom one, just there's less math there. Less math just means less chance for math error. Negative 4 times negative 2 is positive 8. And so we have a final answer of negative 2, positive 8. Word problems. I love word problems. So we're talking about a concert, and we're trying to figure out the price of each type of ticket. That's usually my first stop. Is what am I trying to find out? I'm trying to find out the price of each type of ticket. Well, what types of tickets do we have? Well, we have orchestra tickets and balcony tickets. I am going to make X the orchestra ticket price, and I'm going to make Y the balcony ticket price. Now we do have to make sure that we identify our variables. You do not have to use X and Y. You could use O and B, A and B, whatever. The letters really don't matter. So let's go through and find out what equations we can write. I see 3,640. Okay, I'm not ready to use that yet because I don't know where that's going to tie in. I have an orchestra ticket, that's X, costs equals 3 times a balcony ticket, 3Y. Great. So now I have to do something with the 3,640. How did we get that 3,640? Well, we got it from selling tickets. What did we sell? Well, we sold 148 orchestra tickets and 76 balcony tickets for a total of $3,640. So there is my system. Now look at this. That first one, my X variable is already by itself. So all I have to do to start, now that I've written these, is plug my 3y into X because X is equal to that. So I have 148 times 3y plus 76y is equal to 3,640. If I multiply the 148 and 3y, I get 444y plus 76y. These are like terms, so 444 and 76 is 520y to get 3640. Finish solving for y, divide by 520 on each side, and we get y is equal to $7. Now that we know that y is $7, I can come back to my x is equal to 3y and plug in that 7. And 3 times 7 is 21. And I put money there because we said x is a ticket price and y is a ticket price. So my final answer, remember in word problems we write these out. We would say orchestra tickets cost $21 each, and balcony tickets cost $7 each. All right, this is where we are going to stop for today. Thanks again for joining me. Have a great rest of your day.